2002 Canadian Open Mathematics Challenge, Part B. 2002 Canadian Open Mathematics Challenge, Part B. Square ABCD has vertices 0, 0, 0, 8, 8, 8, 8, 0. The points 0, 5 and 0, 3 are on side AB, and 8, 1 is on CD. What is the equation of the line through Q parallel to the line through P and F? Let's start by drawing a diagram. And let's label this now. So this origin obviously is A. The B is up here, 0, 8. C is 8, 8. And D is 8, 0. And then they've got P, which is 0, 5. That's approximately here. And then 0, 3 is Q. So that's approximately here. And then they've got this F, 8, 1, which is about here, F. Okay, so now what they're saying to me is that they want you to draw a line that's parallel to PF. So first let's draw a PF. So PF is like this sort of. And then they're saying that there's an equation of a line through Q parallel to PF. So there's another line that goes through Q that's pretty much the same in terms of its slope. So something like that, parallel. Okay, so that's about as good as we're going to get here. Okay, that shouldn't be a problem. The equation of this line right here, right there, is going to be y is equal to mx plus b. Obviously, that's the standard form of all equations of lines. But the m is the same as the m for that because they're parallel, they have the same slope. So first let's find the slope of pf. So p is that, f is that. So the m would be the difference of the y values over the difference of the x values, rise over run. And that is 4 over 8, so negative a half. Okay, so that means this also has a slope of negative a half since they are parallel. Okay, and then q is what? Did they give us? Yeah, 0, 3. So q is 0, 3. And then the equation would be y is equal to minus a half x plus b. And then I just have to substitute 0, 3 into this to get the value for b. When x is 0, that's 3. So therefore b is 3. So y is equal to minus a half x plus 3 is the equation that they are looking for. Great. So that takes care of part A. Part B, if the line from part A intersects AD at G, what is the equation of the line through F and G? Okay, so they're saying that this point right here is G. So I will draw that here, G. And I guess the first thing, of course, is to find out the coordinates of G. Well, G goes through the x-axis, right? So that means y is 0. So I have to set y equal to 0 into that equation. So when y is 0, we've got negative a half x plus 3. So that means x over 2 is equal to 3. So x is equal to 6. So that is 6, 0, the coordinates of G. And now they want me to find the equation between F and G. Okay, well, F was what? 8, 1, right? 8, 1. Okay, shouldn't be a problem. So FG is obviously y is equal to mx plus b. M is the difference of the y values over the difference of the x values, which looks like 1 over 2. So y is equal to a half x plus b. Substitute either of those points to figure out the value for b. If I use that one, 1 will be equal to 1/2 times 8 plus b. So 1 is equal to 4 plus b. b is equal to negative 3. Therefore, the equation of fg is y is equal to 1/2 x minus 3. Okay, moving right along to part C. The center of the square is a point H, 4, 4. Determine the equation of the line through H perpendicular to FG. Okay, so H somewhere right there, that's H right there. That's 4, 4. And they want you to find the equation that's through FG. Okay, let's draw in FG first. Let's see here. So from G to F, there, something like that. And then they're saying there's a line that goes directly perpendicular through H and lands on FG. All right. So let's see if I can put something that looks something like that. Okay, I think that's good enough, right? Okay, so it's perpendicular, so that means that's a right angle. All right, so we have to figure out H. Do we want to label that point? Well, I don't think we need to. It's getting kind of messy. So H, let's just say the green line. I think that should be enough. So the green line, which is the equation that we have to figure out. We know its slope is going to be the negative reciprocal of the slope of FG. The FG equation was this guy right here, right? So its slope was a half. So negative reciprocal, first you take the reciprocal, and then you do a negative. That's what it means, negative reciprocal. So because those two lines are perpendicular, one slope will be the negative reciprocal of the other slope. So this slope is negative 2. And the equation is of the form y equals mx plus b. And we figured out that m was negative 2. And then all we have to do is substitute 1 point on that line. 1 point on that line is the h, 4, 4. So 4 is equal to minus 2 times 4 plus b. So 4 is equal to minus 8 plus b. So b is equal to 12. So therefore the equation of that green line is y is equal to minus 2x plus 12. Great. And finally D. A circle is drawn with center H that is tangent to the four sides of the square. Does the circle intersect the line through FG? Justify your answer. Okay. Let's see here. So let's see if we can first draw a circle. So in order to prove or disprove, whatever, that the circle intersects the line through FG, if that was the case, then that would mean that if you drew a line from the center to FG, it would basically be the radius. So what that basically means is that the perpendicular distance would be equal to the radius. Radius of the circle. The perpendicular distance from the center of the circle to FG. And the radius of the circle is 4, since it's boxed into a square of side length 8. The diameter is 8, radius is 4, which is equal to 4. Okay, so we've got the equation for this green line, which is y is equal to minus 2x plus 12. And we've got the equation to FG, which was y is equal to 1/2 x minus 3. So all we have to do is find its intersection, and when you do, you'll be able to find this point that where they touch, and then we can find the distance from that point to h and see if it is 4 or not. Okay, setting these equal to each other, minus 2x plus 12 is equal to 1/2 x minus 3. So that means 15 is equal to 5x over 2, and therefore x is equal to 6. So this point where it touches, whatever that point is 6, and then the y coordinate, sub it back into either one of these. When x is 6, you get 0. Yeah, 0. Okay. So this point right here where those two lines intersect is 6, 0. And we have to figure out if the distance from 6, 0 to the center, 4, 4, is equal to 4. If it is, then that means that the circle intersects that line. Let's see, distance formula. Distance is 6 minus 4 squared plus 0 minus 4 squared, all under the square root sign. And that's what? 4 plus 16, which is root 20. Well, root 20 is definitely not equal to 4. So that means the circle does not intersect the line FG. So therefore, circle does not intersect line FG. Number 2a, let a and b be digits, that is a and b are integers between 0 and 9 inclusive. If the product of the three-digit integers 2a5 and 13b is divisible by 36, determine with justification the four possible ordered pairs ab. We've got two numbers. 2a5 is the first number, and the second number is 13b. And they are saying when you multiply them, the product, it's divisible by 36, so it's 36k. Okay. Now, we've got 36k, which is what? The 36 is 9 times 4, and we can further plug that into 3 times 3 times 2 times 2. And this is where you bring in divisibility rules. Divisibility rules. And there's many of them, but the one in particular that we'll use here is that if something is divisible by 36 in this case, right? So obviously it's divisible by 9 and 4. That's pretty obvious. So that means one of these is divisible by 9 and the other one is divisible by 4. Okay? So which one is which? Well, anything that ends in a 5 can never be divisible by 4, right? Because if you look at values of 4, like multiples, you have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. Well, you get the point. There's never going to be a 5 as the units digit. So that means that this guy here is the one that's divisible by the 9. Divisible by 9. And this is the one that's divisible by the 4. All right. Okay. So we've got that established. Now, 13b, whatever that number is, divisible by 4. And here we go with another divisibility rule, which you may not have remembered. If something is divisible by 4, then that means its last two digits are divisible by 4. Last two digits are divisible by 4. All right. So that means that the last two digits here, 3b, are divisible by 4. So if we look here, the only possibilities are 32 and 36. So 32 or 36. So that means that this b is either a 2 or a 6. Okay, so hopefully so far so good. Okay, so we've got b's either 2 or 6. So let's work with this here now to try to figure out what this can be. Let's start with our b equals 2. If b is equal to 2, we need this 2a5 multiplied by 132. This thing to follow these divisibility rules. Okay. Well, we had previously stated that this is divisible by 4, which it is 66. Yeah, it is. So that takes care of this guy right here. But interestingly, 132 is also divisible by 3. So that means we've taken care of all of these. So all we really need is for this to be divisible by 3, the last guy. So this has to be divisible by 3. And there means we will write out all the numbers in the form 2a5. So we got 205, 215, 225, 235, and so on, right? 245, 255, 265, 275, 285, and 295. So of these, which ones are divisible by 3? It's this one, and this one. So that means that A is equal to either 2, 5, or 8. Great. Now let's go back and look at our B equals 6. We took care of B equals 2. B equals 6. So now we've got 2a5 times 136. And that also has to abide by these divisibility rules. 136 is divisible by 4. And I think that's it. It's not divisible by 3. So that means this whole guy has to be divisible by 9. It has to take the responsibility of being divisible by the other party. Well, that means we got to go back to this list and see which one of those numbers is divisible by 9. And the only one that's divisible by 9 is 225. So that means that A in this case is 2. Okay, so our ordered pairs, when B is 2, it looks like A can be 2, 5, or 8. And then when B is 6, A is 2. So I think that's it. We've got 2, 2, 5, 2, 8, 2, and 2, 6. Yeah. Okay, that takes care of part A. Part B, an integer n is said to be a multiple of 7 if n is equal to 7k for some integer k. If a and b are integers and 10a plus b is 7m for some integer m, prove that a minus 2b is a multiple of 7. So 10a plus b, they're saying, is equal to 7m. And they want me to prove that a minus 2b is a multiple of 7. So it's 7k, let's say. Okay. That shouldn't be too big of a problem. So let's see here. From this equation, I can isolate for one variable. So I'll isolate for b. b is going to be 7m minus 10a. And then I'll substitute that into here. So a minus 2b, which is 7m minus 10a, and that is equal to 7k. But we don't know that yet, so let's just leave that alone. I have to prove that it's equal to 7k. Okay, so this looks like a minus 14m plus 20a, and that's 21a minus 14m. If I factor out a 7, I get 3a minus 2m. Correct? Now, a and m are integers, correct? So a and m, actually. A and b, but a and m also are integers, according to the question. A and b are integers, m is an integer, right? So if a and m are integers, then that means that this 3a minus 2m is also an integer. 3a minus 2m is also an integer. And we can call that whatever we want. We could denote it k. Why not? Call it k. So that basically means that this is 7k. And that's it. That's pretty much what we wanted to do. That's all we wanted to prove. All right, the next part says, if c and d are integers and 5c plus 4d is a multiple of 7, prove that 4c minus d is also a multiple of 7. Okay, so let's move this up here. 5c plus 4d, they're saying, is a multiple of 7, so that's 7k. And we have to prove that 4c minus d is also a multiple of 7, so it's 7m, let's say. Okay, so as always, let's start with this guy here, and let's isolate for one variable. So 4d is equal to 7k minus 5c. d is equal to 7k minus 5c over 4. And at this point, we will now substitute that back into there. So we have 4c minus d. So that becomes 4c minus 7k minus 5c all over 4. And then we get a common denominator, that kind of stuff. Multiply top and bottom by 4. So I get 16c minus 7k. And don't be careful here. This is plus because it's minus minus all over 4. So this becomes 21c minus 7k all over 4. If we factor out a 7, we get 3c minus k all over 4. And that is equal to this 4c minus d. Okay, so now we need to talk about this a little bit. 4c minus d is equal to 7 times 3c minus k over 4. Now, we are told that 4c minus d, we have to prove that it's a multiple of 7. Okay. C and d are integers. So since c and d are integers, 4c minus d is also an integer. Okay. So the only way that can be an integer is if this is an integer, right? Because they're equal. So that means that 7 times 3c minus k over 4 is also an integer. And that is only possible if 3c minus k is divisible by 4. Otherwise, it will be some fraction. So that means that 3c minus k over 4 is an integer. And we can call it, let's say, m. So substituting that, we get 7m. And that's pretty much what we wanted to figure out. Or prove, I should say. That 4c minus d is a multiple of 7. And that's pretty much it. There are some marbles in a bowl. Alphonse, Beryl, and Colleen each take turns removing 1 or 2 marbles from the bowl, with Alphonse going first. Then Beryl, then Colleen, then Alphonse again, and so on. The player who takes the last marble from the bowl is the loser, and the other 2 players are the winners. If the game starts with 5 marbles in the bowl, can Beryl and Colleen work together and force Alphonse to lose? Well, let's see. A, B, C, Alphonse, Beryl, and Colleen, and then A again. And then we'll start off with the number of marbles in the beginning, and then the number taken out. So let's start off with our 5 marbles and see what kind of scenario we can create where Beryl and Colleen are working together to force Alphonse to lose. So he starts off with 5. Okay. Let's say he removes 1, because he removes either 1 or 2. So let's see what happens. Well, if he removes 1, that's not under the control of Colleen or Beryl. They have to sort of wait to see what he does. If he removes 1, Beryl then has 4 that she begins with. She's going to remove 2. That means Colleen will start off with 2. Colleen will remove 1. Alphonse will then end up with 1. And then, according to the question, the player who takes the last marble from the bowl is the loser. So that means A loses. Okay, so that is the strategy to make A lose. Now let's continue this, right? Because what about if Alphonse removed 2? He can also remove 2. That's another one of his choices. Okay, let's see what the strategy would be for B and C, Beryl and Colleen. He, therefore, if he removes 2, Beryl would get 3. Beryl would then remove 1. Colleen would then have 2. She will remove 1. And Alphonse, again, will end up with 1 and therefore lose. So there you go. So if you start off with 5 marbles, Alphonse in particular starts out with 5 marbles, there's always a strategy that Beryl and Colleen working together can have that will make Alphonse lose. And this is basically the strategy right there. So it's pretty straightforward when there's only 5 marbles. Next is the game is played again, this time with n marbles. For what values of n can Beryl and Colleen work together and force Alphonse to lose? All right, so now this is different because we don't know what n is. So here we go. So we're going to start with values of n equals 1, n equals 2, kind of go up there, and then eventually we'll extrapolate because we can't go on forever, right? But one thing I hope you notice is that when n is equal to 5, this is the strategy. So this is the strategy. So when n equals 5, there exists a strategy that Beryl and Colleen can, working together, can implement to ensure that Alphonse loses. So what we're going to do is we're going to make a list here of values of n for which Alphonse loses and for which Alphonse wins. Alphonse wins basically means that somebody else loses. So either Beryl or Colleen loses. Okay. So we already know that when n is equal to 5, Alphonse will lose for sure because Beryl and Colleen always have the strategy. All right, so that we don't need to worry about n equals 5. That is something we've already proven. But we need to figure out what other values of n are going to end up in this column or that column. All right, so just as before, let's make a table and off we go. So let's start with n equals 1. We've got Alphonse, Beryl, Colleen, sorry. Okay. Well, if we start off with 1, then Alphonse is automatically loses, right? Because the person with 1 marble loses. So that's really pretty just straightforward. So n equals 1, Alphonse loses. Okay, not much to discuss there. How about when n equals 2? When Alphonse starts off with 2, if he removes 2, that's going to end up with 0, so that's invalid. So he's got to only be able to remove 1. So if he removes 1, that means Beryl ends up with 1. Since Beryl ends up with 1, she loses. So Beryl loses, so B loses. If B loses, A wins. So n equals 2 is in this column. It's a value of n for which A wins. Okay. So far, hopefully, it's not too bad. N equals 3. If Alphonse starts off with 3, we've got a couple choices. The first choice is when he removes only 2. Then Beryl ends up with 1. Beryl loses. But what if he started off with 3, but he removed only 1? Then Beryl ends up with 2. Beryl has no choice but to only remove 1, and the next player, who's Colleen, ends up with 1. Colleen loses. So in either case, A wins. So n equals 3 goes here. Okay. N equals 4. Here we go. keep on going. N equals 4, A, B, C. If he removes 2, B gets 2. She has no choice but to only remove 1. C gets 1, C loses. And keep in mind that Alphonse is trying to win also. He's not trying to lose. So that's why he's going to remove 2. Because he knows that if he does that, C will lose. So if C loses, Alphonse wins. So N equals 4 ends up in this column. Okay, N equals 5 we already did in part A. How about N equals 6? Let's see here. If N is equal to 6, then A, B, C. Let's see here. Start off with 6. If he removes 2, we got 4. If we start off with 4, if B and C are working together to make sure that Alphonse loses, the strategy would be remove 2 here, end up with 2, remove 1 here, and there you go. A would lose. But what if Alphonse removed only 1? Then what would happen? Then you would have 5. The strategy would be remove 2. This would be 3. Then remove 2 again. And this would be 1. So in both cases, Alphonse loses. For N equals 6. All right. Let's keep going here. How about N equals 7? A, B, C. If N equals 7, start off with 7. And if he removes 1, we get 6. And if we get 6, then whoever starts off with 6, regardless of what happens, will lose. So just like here, A started off with 6, regardless of what happens, lose. So B starts off with 6, so regardless of what happens, there's always a strategy to make that person lose, so B loses. Okay? Because everybody's trying to win, so everybody's going to make the best possible choice for themselves. But what if you start off with 7, but you remove 2? Then you end up with 5 for B. And remember remember when it's 5, whoever starts off with 5, as we showed in part A, will also lose if the other 2 make the right decisions. So you're just kind of using the other scenarios to help you out here. So that means B loses again. So if B loses, that means A wins. So N equals 7 goes into this column. How about N equals 8? If N equals 8, we got A, B, C, and A. If we subtract 2, that means B is 6. And remember, just like here, if B starts with 6, B can lose. B loses. However, if Alphonse only removed 1, B ends up with 7. If B starts with 7, the next person will lose. Just like here, A started with 7. The next person with C was C. C lost. The next person here is C. Sorry, the next person in the previous one was B, and B lost. In this one, the next person is C, so C would lose. So C loses. And in both cases, A would win. So if A wins, N equals 8 goes into here. So hopefully this is making some sense. And then I think we only have to do one more. Well, I'll do just one more, and that's N equals 9. If N equals 9, we got A, B, C, and then A. If we start off with 9 and he removes 2, we get 7. Correct? And then they're going to make the right decisions here. So B will only choose to remove 1. That will be 6. C will only choose to remove 1, leaves A with 5. And if A starts out with 5, he will lose. So A loses. But what if 9 was what they started with, A, and then he only removed 1? Well, this will be 8. B will choose to remove 1, which will be 7. C will choose to remove 2, and then we're back to 5 again. Again, A will lose. So when n equals 9, both B and C can work together to ensure that A loses. So A loses, n equals 9 goes into here. And then you guys get the point. If you extrapolate this, meaning n equals 10, n equals 11, and so on, you will find that for every n that's greater than or equal to 9, you can create a scenario where A loses. And it really has to do with just repeating what we've already done. You notice how once I got down to A equals 5, A loses because of what I had done previously up here. And similarly, if you can get it down to 6, same thing. A will lose. So for any number greater than or equal to 9, you can get it down to one of these numbers, either 5 or 6. And when you do, you just proceed with what you do when it is n equals to 5 or n equals to 6 to ensure that A loses. So that's pretty much the strategy. Triangle DEF is acute. Circle C1 is drawn with DF as its diameter, and circle C2 is drawn with DE as its diameter. Points Y and Z are on DF and DE respectively, so that EY and FZ are altitudes of triangle DEF. EY intersects C1 at P, FC intersects C2 at Q. EY extended intersects C1 at R, and FC extended intersects C2 at S. Prove that P, Q, R, and S are concyclic points. Okay, so when they say prove that they're concyclic, what does that mean? Prove P, Q, R, S concyclic. What that means is that these are all on a circle. So S, R, P, Q are all on a circle. If this is S, this is R, this is P, this is Q. And that is proven if you take a point, usually the center, and extend it to those points, and those are all equal because those are all the radii. Correct? So that's sort of the strategy. So here we go. Hopefully this will be relatively understandable, I hope. Okay, so the first thing I would like to talk about is DE. DE is the diameter of C2, right? They tell you that in the question. So DE is the diameter of C2. C2 is this circle. Okay, great. And therefore, QS, which is this right here, is perpendicular to DE. Now, the reason we know that is because if you recall, DF is the diameter, correct, of this second circle from there to there. So what we had done is essentially drawn a triangle like that. And because DF is the diameter, that triangle will have a right angle. That's just a rule, that if you draw any triangle within a semicircle, it will be a right angle triangle. And then what we did was we just extended that line all the way till the other side like that. So that is perpendicular to that. So QS is perpendicular to DE. And therefore, we can conclude that DE is the perpendicular bisector of QS. Because DE is the diameter, so any line that is perpendicular to it will basically get cut in half by DE. And in this case, the line we're talking about is QS. Now, if I connect a line from D to Q, so I'll just connect it. So I'll put it in red here. D to Q, like this. That helps me out a great deal because now I can conclude that DSQ, that triangle, is isosceles, right? Because that's a rule. If you have an isosceles triangle and you draw a perpendicular, and if it cuts it into half, it cuts it into half, basically. That's the rule, where that only happens in an isosceles triangle. So based on these conditions, DSQ is isosceles. So we can conclude that the side DS is equal to the side DQ. All right? So I hope that makes sense. In a very similar way, on the other circle, DF is the diameter of C1, right? The other circle. They told you that in the question. And very similar to what I just did, this time PR is perpendicular to DF for the same reason, right? Because if we were to draw a diameter DE, which is what it is, and then draw a triangle in that semicircle, by law, that is a right angle. So that's why we know that that line PR is perpendicular to DF. And therefore we can conclude that DF is the perpendicular bisector of PR for the same reasons as before. And therefore we can conclude that DPR is isosceles. DPR triangle is isosceles. So let's draw in that triangle. So what is it? DPR. So we're going to need that line, and we're going to need a line from D to P. So there we go. There's another isosceles triangle. So we can conclude that DP is equal to DR. All right, great. So that is the beginning of this solution. Try my best to keep it all on one page, but I might have to extend it, but let's just see if we can keep it all on one page. We can squeeze this a little bit, give us a little bit more space. All right, so here we go. Let's continue. Now, we can use Pythagoras at this point. ds and dz and sz. In particular, we are talking about this triangle right here. So let's clean this up a little bit here. Let's erase that blue stuff. And then, in particular, what I'm referring to is this triangle right here, DSZ. In DSZ, we can conclude from Pythagoras, since it is a right triangle, that ds squared is equal to dz squared plus sz squared. Now, DE is the diameter, correct? All the way from there to there is the diameter. DE is diameter of that circle. Because it told us that in the question. So therefore, if you were to connect this, this becomes a right angle. And I think I had described that earlier. So let's do that. Let's connect those two together and show you that you're creating basically a triangle within a semicircle. And by law, that would be a right angle. So let's just put in that right angle right there. Okay. So, therefore, angle DSE is 90 degrees. Okay, great. So what we've done basically is we've created a similar triangle situation. That DSZ, that triangle, DSZ, is similar to triangle SEZ. And if that's not obvious, what I'm going to do is I'm going to draw both those triangles out. So first, let's draw DSZ. So DSZ, D, S, and Z. And let's label the angles. Now we know this is the right angle. That one's in the diagram. That's a right angle. We know that. But we haven't labeled any other angle, so I'll just label that theta. That angle right there, which is sort of that angle right there. Okay, great. So then the third angle is obviously 90 minus theta. 90 minus theta. Okay, now let's draw the other triangle to prove that it's similar. And that's SEZ. So SEZ, this guy right here. So let's draw that. SEZ. So that one has also a right angle. Like that. Now remember I denoted that to be theta, right? Well, if that's a right angle, then this angle will be 90 minus theta, that angle. So that means this angle is 90 minus theta. So let's just put that in there. This is 90 minus theta, and therefore this will be theta. So as you can see, those two triangles are indeed similar since they have the same angles. Now, using similar triangles, the ratio of the sides, DZ over SZ, will be the same as SZ over EZ. Cross multiplying, you get SZ squared is equal to DZ times EZ. Correct? So now what we can do is we can plug this back into our Pythagorean relationship. So DS squared is equal to DZ squared plus DZ times EZ. Like that. All right, let's move this up a bit. And then this will be, if you factor out the DZ, DZ times DZ plus EZ. And DZ plus EZ, this guy, if you look back at the diagram, DZ plus E to Z is all the way from D to E. So we can just substitute that in. This is actually DE. So this is DE times DZ. And that's equal to DS squared. And in a very similar way, similarly, using the other circle and all that stuff, you can show that dr squared is equal to dy times df. And I'll let you do that. It's pretty much the same scenario as what I just did, but on the other circle. And then now finally it all comes together. There's something known as the secant theorem. And in this particular the diagram, the secant theorem would be that dz times de is equal to dy times df. So that is the theorem. It states that dz in this particular diagram times dy is equal to dz times de is equal to dy times df. So if we look at these two equations, dz times de is here, dy times df is here, and those two are equal, so therefore ds squared is equal to dr squared. And therefore ds is equal to dr. All right, so now we can combine this finding with this finding and this finding. ds is equal to dq, dp is equal to dr. So let's write that here. ds is equal to dq, and dp is equal to dr. Well, now we've got a chain here. dq is equal to ds according to this guy, ds is equal to dr according to this guy, and dr is equal to dp according to this equation. So there we go. We just proved that dq is equal to ds is equal to dr is equal to dp. And that basically means that we have it all on one circle. If D is here, which is the center, we have shown that dq is equal to ds is equal to dr is equal to dp. All of these are equal, and that proves that these 4 points are concyclic. Challenging question, but I tried to explain it in simplest terms, and I encourage you to learn this question because it involves a lot of very important mathematical concepts.